Welcome to Climbing the Immune Ladder Steps for Success in Science, the iiSIAR podcast, the show where we explore inspiring experiences in science and the untold stories shaping our community. Today, we will be your hosts. My name is Salma, postdoctoral fellow from the University of Montreal, and
my name is Chiara Testini. I am a researcher in immunophysiology at the University of Uppsala in Sweden.
In each episode, we will dive deep into conversations with experts on innate immunity, in sterile inflammation, autoimmunity, and their resolution to bring you insights, ideas, and inspiration you won't hear anywhere else. Whether you're tuning in during your morning coffee or while you're doing your lab bench work, get ready to learn, laugh, and see the world from a new perspective. Let's get started. Today's expert is Professor Jesmond Dalli from Queen's Mary University of London. Thanks for joining us and welcome to our podcast.
My pleasure. Thank you for inviting me.
Could you please tell us a bit more about your line of research?
My lab is interested in understanding mechanisms that regulate inflammation, and we're particularly interested in studying mechanisms that reprogram immunity to limit inflammation without immune suppression, with a focus on a group of mediators that are termed as specialized pro-resolving mediators. These are molecules that are produced from essential fatty acids. They're produced via specific enzymatic processes that convert the fatty acids to a defined molecule, and that these molecules then engage the host immune response through specific G protein coupled receptors, or at least as far as we can tell, they do this via G protein coupled receptors, and they reprogram the target cell to perceive the environment in a less of an inflammatory manner, as well as to activate repetitive and host protective mechanisms.
Thank you, Jesmond. Can you briefly share with us about your trajectory in science?
That's an interesting story. So I am Maltese, so I grow up on a tiny island in the middle of the Mediterranean, and as anyone who grows up on an island does, or the majority do, we grow up enjoying the marine environment. So I am originally a marine biologist. My undergraduate and my master's degree are in marine biology, conservation biology. And then eventually I decided that being out in the cold and the wind 365 days a year may not necessarily be my career. And so I was fortunate enough to move to London, where I was offered a PhD in biochemical pharmacology with Mauro Peretti. And that got me very interested in the innate immune system and understanding mechanisms that limit inflammation. And over the year, I grew particularly interested in phagocyte biology, starting off with the neutrophil, which is one of my most favorite cells. And we've recently expanded into other innate immune cells, but the neutrophil still stays up there. And then over the years, once I finished my PhD, I was offered the opportunity to move to Boston to work with Charlie Serhan. And that's where my love for resolution biology really started and really grew. And from then on, it's sort of been following on the biology that we've been observing as we were studying mechanisms that are linked with the resolution of inflammation, with a focus always on innate immune cells and pro-resolving mediators.
And a part of these opportunities you had with this amazing scientists, what initially drew you to the field of immunology and innate inflammation and its resolution?
I would say serendipity by and large. As I mentioned, I started off as a marine biologist. What I left out in my description was that I did spend a little bit of time as an environmental chemist, looking at gases emission from both farms and cars, and somehow bouncing off different people and different opportunities, I landed in Mauro Peretti's lab, and that's where sort of the direction started from. In this innate immunity and resolution mechanisms, and what kept me in the field is one, the fact that we really do not understand the fundamental mechanisms that limit inflammation very well, and the immense potential, as part of my PhD, I had a big grounding in pharmacology. And so I always have an eye out on what can we leverage out of what we're learning to build better drugs for the future. And I think resolution biology has a strong potential to give us much better, much more effective, and potentially drugs with less side effects than what we currently have. So this is what's kept me in the field.
Beyond the scientific curiosity and this unplanned serendipitous event, do you have any personal motivation which has driven your work in immunology?
Not necessarily. I enjoy what we do. That's my personal motivation. I enjoy the work that we do. I enjoy pushing boundaries on things that I personally can do. So learning new things, and also on discovering new concepts, discovering new ideas. Those are the things that drive me and in the work that we do.
Could you highlight, please, a key discovery or project you're the most proud of in your career and how it impacted the field?
I'm not sure there is one single one that I would say is a key discovery. I think time will tell what will be a key discovery. But what things that I am particularly excited about is, for example, that we found a class of mediators that are peptide lipid conjugated mediators. That, as opposed to the only known other peptide lipid mediators, which are the cysteine and leukotrienes, these mediators have potent tissue reparative mechanisms, and they do so via epigenetic rewiring the target cell. And I think for me that was very exciting because it showed how flexible biology is, how diverse biology is, where a similar backbone, if you will, a peptide molecule with a fatty acid backbone, can have such diverse functions, from cysteine which are vasoconstrictive, they cause hyperinflammation um, and vasodilation, to pro-resolving mediators that promote tissue repair and tissue regeneration. And in the lung, they actually counter-regulate the effect of cysteine leukotrienes. And I find that fascinating, that small molecules with slightly different physical properties can have such a diverse biology.
It's really interesting that these molecules are so similar and then do a complete different effect. Yeah. And how is your process on identify these high impact research question that you had in discovering this molecule, for example, or other project that you have developed? What was your thinking?
The way I perceive biology is, in biology, nothing is there as a redundant mechanism. We understand things as being redundant because we don't know what else they do, and they seem to be doing similar things. And so we're always interested in trying to figure out why something is there and what is driving that specific biological process. And for example, in this particular context, the question that we were trying to address is, we know there are mechanisms that limit inflammation and promote the return to homeostasis from an immune perspective, looking at less cells at the site of inflammation, less pro-inflammatory molecules. But when you have tissue injury, at that point, once you've controlled the inflammation, you need to start repair. Otherwise, you may have less inflammation, but the organ is still damaged. And so there has to be a molecular process that signals, okay, we're turning off inflammation. Now we need to start repair. And that's where we tried to where we focused on, at that interface between resolution and the next step of repair, to identify potential targets, potential molecules that can guide this process. And this is how we identified the first family of mediators, the maresin conjugates and tissue regeneration. And that provided a guide that there might be other similar acting molecules that might be site specific, tissue specific, and we identified some additional families at a later stage. So it's really trying to understand how biology is functioning and what are the molecular cues. We obviously have a bias. We have a bias towards lipid mediators as a molecular cue. And so we're focusing down on trying to see whether there are other signals that we've so far not identified. And this was one of the examples where we identified a new family of mediators with potentially a new biology.
Quite interesting. Science is a journey full of challenges. Could you share with us which strategies you're using to help you push through these toughest scientific challenges?
Yes, I would say several different strategies, and we're always looking for new ones. So one challenge is that when you're trying to address new biological questions, new questions, you need to approach a question from many different angles. One, because you want to make sure that the answer that you've got is potentially a correct one. And secondly, because sometimes the next question is not an obvious one. And it's always good to get input from outside on what could be the next question to ask. And so this brings me to the point that it's good to have a strong network of collaborators, people that you are happy to discuss work with, that can provide you insight, information, and anyone from, for that matter, the general public has a lot of information, a lot of insights that they can offer into why certain questions are important, from a health perspective, from a quality of life perspective, and so on. Whereas colleagues then can provide input also on specific biological questions or techniques or approaches that can be used. Um, and then the other thing is having a good work-life balance, because there's always things to do. And there's always papers to write, there's always grants to write, there's always experiments to do. And sometimes it's good to get out and to sort of switch off for a short period of time, because it provides a different perspective.
Since you already mentioned this, we can talk a bit about work-life balance. What do you do to maintain this work-life balance? What are your hobby? What drive you on the other side also?
A number of things. So I always like sports. I enjoy a whole range of different types of sports, from football if you're in Europe, or soccer if you're in the on the other side of the Atlantic, um, to volleyball, to scuba diving, to mountain climbing, to all sorts of things. Anything that gets me outside. But then there's also family, and I have two young kids, and it's always good to spend time with the kids, playing, sometimes doing homework, them complaining, but it's unplugging and getting away from the general sort of routine, and I think that's important. It's also good to set boundaries as to sort of when and where work is done, because it helps keep a bit of a separation too. Doesn't always work. I'm not saying it always works, um, but in general it does.
It's a good advice. Can you share with us, please, any crucial decision or opportunity you had that significantly advanced your career?
So one opportunity that I had was to move to the US, for a number of reasons. When I finished my PhD, it wasn't in my plan, and at the time, my partner's plan, for us to move to the US. And we were looking for postdocs across Europe. At the time, we were successful in identifying positions, at least for both of us, because my partner is also, my wife now is also a researcher, so it was very difficult for both of us to get a job in the same city. And then an opportunity came up for both of us to move to the US. Um, and after discussing it, we realized that it was likely to be a very good opportunity, and indeed it was after a few years. So I think that was potentially one of the big opportunities that sort of was unanticipated, but had made a big difference.
There are many opportunities that come out sometimes during science, and you have to make choices while managing existing commitment. how do you evaluate and decide about this new opportunity?
Yeah, that is a very difficult one. Also because I find it very hard to say no. And so I would say this is probably one of my personal weaknesses of deciding which opportunities to let go and which ones are not. And I usually overload myself. Um, but I would say I evaluate on a number of factors. One, my available time. Two, how does that fit with the strategy and the interests that as a lab and as a group and as a community we have? And three, I tend to prioritize helping more junior colleagues because when I was at, and I still am at positions where I need help, um, I always appreciate someone stepping in and providing a bit of assistance. So that's one of the things I'm not very good at, but in general, those are the criteria that I tend to use.
And looking back, were there any career moves you initially doubted that turned out to be maybe right or wrong choices?
So when I moved to the UK, that was probably one of the moves that I was very unsure about. After abandoning marine biology and sort of moving into more laboratory sciences, um, that was for me a big decision because I did like the marine biology side of things. I just wasn't quite sure it was where I wanted my career trajectory to go, and also there was very limited opportunities at the time. And then it was unclear of what field would be the one that would be of interest because I had limited laboratory experience at the time. And this is where I was lucky that opportunities came up that aligned with my interests and helped me refine my interests as I moved along. But I would say I was always open to new adventures and new opportunities, and then tried to adapt and mold things to sort of make it work.
What non-scientific skill have been most critical in your career progress, and how did you develop them?
Non scientific, I would say being able to adapt to situations, um, and being able to communicate with a whole range of different people. I would say those are the two critical skills that have helped me a lot, and I developed them as I had the opportunity as I was at university as an undergraduate that I was also a scuba diving instructor. And that allowed me to develop a lot of these soft skills through teaching. And I was lucky that the courses that I took at the time were very good at developing such skills. The scuba diving courses, the instructor courses were very good at developing such skills. And then I had the opportunity to do quite a lot of teaching and management at an early-ish age, I would say. So those I think are really important skills because you interact with so many different people in academia and in sciences in general. And then once you become a PI in particular, that you need to manage different people. You also have other commitments that you need to manage. And I think it's good to be able to keep a level head.
It's quite challenging whenever you have a lot of stuff to do. And staying current with scientific advancements is also another challenge. How do you manage with keeping up and continuously fostering your professional growth?
I cheat a little bit. So what we tend to do is during our lab meetings, everyone presents a paper. So I get snippets of papers from my group. So that way I read or at least know what's in an abstract for about 10 to 15 papers a week. And that helps to some extent. And I also use a lot of the available updates like PubMed sends updates for keywords. And there is other services that one can use to get updates for papers. it's a challenge, and it's becoming more of a challenge because there's so many journals out there, there's so many papers that come through, and we also have a quite a broad interest in a lot of different areas, so it is not easy, I must admit. And usually the focus comes down to when writing grants and writing papers, because then you got to make sure that you're as up to date as possible so that you're not overstating or misstating things. But I think it's equally important to keep in touch with the close field, with an opportunity to also branch out every now and again, because there are ideas in other fields that might be useful. And so this is where it's good to interact also with other people, and attending, for example, local seminars. We have quite a few seminars locally in London in particular. It's really good because there's a lot of universities, so you can pop into different universities for the seminars, and that's also very useful.
I have a really strong curiosity because your background is so out compared to many other. Do you still also read marine biology paper? I mean, that was before your graduate, so it might be really a bit like not even interested.
I wouldn't say I keep in touch, because I would be lying, but I do every now and again, um, try and see what's happening. I do very much. It's still very much of a passion of mine, and so I get fascinated. And in particular, my interest of sharks and rays, and it's still very much so. And my kids get get bombarded every time there are documentaries, because daddy's got to watch it. But yeah, I wouldn't say I could hold an educated conversation on the topic, but I'm certainly a fan. So,
Okay, thank you.
I know we can talk for a long time on this, but I don't think it's the scope.
Unfortunately, not. What skills do you feel they're often overlooked, but yet essential for success in both science overall and specifically in immunology?
I think in science overall, people skills are very important, and being able to communicate effectively with a range of people, in particular nowadays, where it's not just reaching out. We have this whole idea of we need to reach out to the public, which I very much agree with, and as scientists, we need to do a much better job at communicating what we do to the general public. But I think sometimes we don't even do very well communicating it with other colleagues from different fields, what we do and why we're interested in it. And given that science has stopped being what it used to be at the time of Sir Isaac Newton, where an apple falls on your head and you've made a discovery type of thing, um, it's not a single field, it's multidisciplinary. We need to be able to integrate a lot of different information from different expertise. I think we need to get better at communicating our work in a broad context and with a broad relevance. And I don't think we do much, or at least I speak for myself. I think we need to get much better at it. Um, and in immunology, I think we gotta think around that it's not one cell type that does this and one cell type that doesn't, and that actually most cell types are a bit of a gradient, and we're just simply capturing snapshots, and we tend to sort of um, put different labels on different cells, but rather we're looking at a big continuum. And so it's trying to understand things from a bigger perspective that potentially may help. Although that's my personal bias now, that may help in really capturing a bit more of the complexity.
No, it's for sure something that immunology is also learning with new tools and technologies. So maybe the field will move more towards your hypothesis. Yeah. Um, what's the most valuable piece of career advice you have ever received?
Follow the data. Always follow the data, and that always resonates in my mind. We like hypothesis. We tend to embrace hypothesis because we're trained to do hypothesis testing. But ultimately, what really matters is the data. Um, and and it might go against your hypothesis. Other people may disagree with what you observe or what you report, but what matters is the data. And we may not understand it, and that's fine. And sometimes we've had situations where we've had to park a piece of data for months and even sometimes years because we just couldn't understand what it meant. But eventually we learned something else somewhere else, and then this made sense. And so I would say that's potentially the biggest thing for me.
And what advice would you give to someone that is just starting in this research field as a new generation?
It's very exciting. There is a lot to do. Don't get distracted by the lot. Focus on what's in front of you because it's very easy. And I am speaking again from personal experience because I have this thing that you see a lot of different things and there's so many things that are so exciting that you get distracted. I think it's good to focus on one thing and keeping an eye out on what there is, but to focus.
Did you have a specific mentor, or which role mentorship played in your whole career, since you also changed field?
Mentorship is very important. Some time ago, I was having a conversation and someone told me that it takes a village of mentors to make a professor. And recently, I've had the opportunity to reflect on this, and it does. At least for me, there was many people who helped shape my career in different ways, and I've been lucky to have some very understanding, very strong mentors that were there to provide advice of different levels, professional, personal, at different stages of my life. And I think it's important to find people like that because you cannot do it on your own. Especially nowadays, we're constantly being asked to do different tasks in addition to what we, as basic scientists, are trained to do. And it becomes very challenging to balance everything. And so it's important to have people who have experience, life experience in these areas to help guide you through these difficult times, but also some challenging questions, but also to help guide you develop skills to ask the next question. As you're developing from a PhD student to a postdoc and so on, that's where you're learning how to ask questions. And it's important to find people who help you with that because at least for me, it wasn't a natural process. It wasn't something that I immediately knew how to go about making the next observation and so on. So it's good that you have guidance around.
Have there been any sacrifices along your career path? And did you ever thought, what if I have chosen differently?
So sacrifices, yes, many. Going to the US, for example, I was far away from home, far away from family for 5 years, and also sort of different lifestyle, different culture, different a lot of things, very long hours. Won't go down that route. But those for me, I wouldn't call them difficult sacrifices. For me, it was second nature. I enjoyed what I was doing. I loved what I was doing, and that drove me to push things to do more. And equally on this side, being a PI doesn't mean that I go home at I wake up at block. I go home at 4 o'clock and life is done. There's a lot more that needs to be done, but I'm happy to do it because I enjoy what I do. So I wouldn't call it as a difficult decision. It still takes time out of potentially other things that I could be doing. Do I regret it? No. It's a very simple answer. I wouldn't be doing it if I regretted it. And that's always been my red line. The minute that this stops being fun, I'm diving.
Literally, I suppose. Like,
I back up and I'm being a scuba diver.
yeah. Um, Yeah, it's good to have some backup plan, let's say.
Indeed.
Let's look at future generation. What challenges and which opportunity do you see for the next generation of scientists?
So I would say challenges at the moment. I think one of the biggest challenges is this idea that we are still not very good at communicating what we do. And that has created, at least in some societies, it has created disconnect between what scientists are doing and what anyone else can say that science. And we're seeing a lot of narratives coming out from many different places around sort of misuse of information and the and narratives around science being manipulated to fit a specific narrative. And I think that's a problem that scientists, as we move forward, that we're going to have to figure out how to address it. Well, this is why I was also emphasizing our the importance of being able to communicate things, because I think we're not very good at doing this, and so other people have taken a narrative in their hands. But at the same time, I think expansion of a lot of the tools that we have, including AI, has provided immense opportunities for us to be able to understand more complex questions. So everything that we've studied, if you think about it, and this goes for our work, we study, for example, proteozoan mediator biology. But proteozoan mediators do not exist in a vacuum. They interact with other molecules, they interact with other cells, different cells interact together. And my tiny brain can't put all that together because there's too many variables moving around. So if you look at papers, it's always focused on one thing, one mechanism, one cell type, one context. But biology is complex, and I think AI will help us address that complexity and bring a new level of discovery that so far we have potentially started to scratch on. And so I think there's going to be immense untapped potential.
Do you have any standout moment from your career? Perhaps something lighthearted, surprising, or funny, out of the ordinary that happened to you in the lab at the conference that you feel comfortable sharing with us?
Oh, there's many of those moments. So, going to meetings and catching up with friends that you haven't seen for many years, sharing data with people. Um, I would say and for example, in the lab, one of the biggest moments for me, seeing my first PhD student graduate, seeing she when she joined my lab, she was a master student, and then going through the whole process, especially as your first student, to a fully fledged investigator, was like seeing your child going to school for the first day. They were teeny tiny, and now all of a sudden they're a little person. And so but then with every student that comes through, and again, you see students going through, coming to the lab, sort of some with varied level of experience and expertise. And then towards the end, they're confident in what they're doing. They've taken ownership. There is a trajectory. And for me, it's always very fulfilling to see that. As a mentor, I would say. Um, and then obviously the other side of it is when some of the experiments work, in particular the ones that were a lot more challenging. And I would say one of the more challenging experiments for me was the structural elucidation of these peptide lipid conjugate mediators, because it took about 2 years to get something that was convincing enough to share with my mentor at the time, with Charlie. Um, and that was nice. That was nice when you could see it in front of you and say, I'm not chasing a ghost anymore now. I know what I'm looking for. And so those are fulfilling moments. Those are the things that make the difficult days good, or at least acceptable, so that because there's going to be other good days.
Another curiosity, do you celebrate, let's call it victory, like do you spend time celebrating article publication?
We have a tradition that for every bit of positive news, there's spumante, as the Italians call it, and cake every time. So some days it's party regularly. Other days it takes a few months before we see one of those, but we make sure every little victory is a victory. And again, those are the moments that help the difficult moments go past. So we definitely underline the good ones.
It's really important. Do you have anything else that you would like to share with us to the future scientist or?
Yeah, my motto is enjoy what you're doing. And it's critical to enjoy the work because that's what provides the drive. And there is loads of opportunities out there. There's a lot that we still don't know. There are a lot of tools that can be used, and there are a lot of people who are happy to support and to help you through the difficult moments. So do identify those people and don't feel shy to ask for help. The advantage is that in academia, we have a little bit more freedom than there is in the industrial side. But at the same time, there are still people who are happy to support and happy to work together. So reach out and enjoy. It's critical to enjoy what you're doing.
Well, thank you. That's a wrap for today's episode of Climbing the New Ladder, Steps for Success in Science, the iiSIAR podcast. A huge thank you to you, Jesmond, for sharing your insights, stories, and experiences with us. We hope you found this conversation as inspiring and thought-provoking as we did. If you enjoyed the episode, don't forget to join us on the next one and share it with anyone who might benefit from it. You can also follow us in our webpage to stay updated on future episodes and innate immunity updates. Thank you for listening, and remember, persistence and asking the right questions are what drives science, and maybe even your own journey. Until next time, stay curious.